The measures of the angles of a triangle are shown in the figure below. We'll solve for x, which is really just the measurement of this missing angle right here, okay? So we have this angle which is known at 46 degrees, and this one right here at 78 degrees, okay? So what we learned last time is if you were to take these three angles, so I'll start with the green one, which is 46 degrees, and then the red one at 78 degrees, and then the unknown angle, which is just, we'll call angle x. If you were to take these three, add them together, they create a supplementary relationship, which means they add up to 180 degrees, okay? Again, it doesn't really matter which method you use. Again, some students would prefer just to take 180, subtract 46, subtract 78, and that works. But I'll work through the equation though. So in my calculator, I got 46 plus 78, and I got 124. And so if I were to add that to x, angle x, I should get 180 degrees. So now I'm looking at an equation which should be not too bad to solve. One principle of equality will do it. The 124 I want to zero out, so minus 124. It's just if I do it to one side, I got to do the other side. So that zeroes out. I can drop my angle x, which is the angle we're solving for, and then 180 minus 124, 56. So again, I'll label this, since I'm doing it by hand, as degrees. But this means that if you were to add all three of these together, then you would get 180 degrees. So that's a nice review of what we saw last time. Today it's pretty much the same thing, but instead of them or us solving for one specific angle, I guess we may be solving for two, but now some of the angles are going to be shown as expressions instead of just one individual value. So I can solve equations made from the inside angles of a triangle. That's the point. We can do that by the end of the lesson, then the assignment will be pretty easy, and then if we see the stuff on the test, that becomes pretty easy too. But take 15 seconds and copy this down, please. So on the bell work, by the way, we did make an equation and solved it. Of course, with those types of situations, you may not need an equation, but for the most ones that we're going to see today, you probably will. So triangles and supplementary angles, this is what we saw last time as well. Triangles, the interior angles of triangles will create a supplementary angle relationship, meaning the three angles from the inside of the triangle, if you were to add them up, you should get 180 degrees. That's what supplementary is. And we saw this last time. If you were to combine all three angles, you would get eventually a straight line. So yeah, the three angles in the triangle, they are supplementary. It's just now we may see one or more of the angles as an expression with a variable. We're going to have to solve for that variable. Like this one right here. Okay, the measure of the angles of a triangle are shown in this figure. Very nice. One of the angles is not being shown numerically. That's this little box mark, but we remember this not just from last time, but I believe the time before, that means it has to be a 90-degree angle. Okay, so again, that's just in case we've forgotten that. So I've got my green angle. I see this angle here at 39 degrees, and then this one, see, that's an expression, 2x plus 1, but it's still fine if it's an expression like that, because the point here is that we're going to be able to solve for x. So I get my three angles together. I got the 90-degree angle. I got the 39-degree angle there in red. And then I got the purple angle, 2x plus 1. Okay, so there's my three angles, but if I were to add these together, I need to get 180 degrees. Okay, well, this just becomes an equation that I got to solve, and that pretty much will finish it because we're trying to solve for x. So I would start off by combining like terms, and I got three constants, 90, 39, and 1, which when I add together gives me 130 right there. And then I can drop my positive 2x. Okay, and this, well, it still equals 180. Okay, so there's my equation that I must solve. I combine like terms. There was no need for distribution, and that's good. But now that I'm at this point, I'm ready to use some principles of equality. So start out, I will get rid of the 130. Okay, I'm going to zero that out. That's what I mean by get rid of. And to do that, I'll subtract 130. Just, it's a principle of equality now, so if I do it to one side, I got to do the other side as well. So that will zero that out. I can now drop my two x's, which equals 180 minus 30, which is 50. And the last thing here, because all we got to do, again, we're just solving for x. Still the principle of equality, though, is I'll have to divide both sides by the coefficient of x to make it 1x. And yep, principle of equality, if you do it to one side, you got to do it the other side. 50 divided by 2 is 25. So 1x would be the same as 25. Meaning, this angle right here, if you replaced x with 25, well, let's see what that angle, they're not asking for this angle, but you could. You could say 2 times 25 is 50 plus 1 is 51. Okay, so we solved there. I'm not going to show the math because we don't necessarily need it, but you could. So if you add these three angles together, 90 plus 39 plus 51, would you actually get 180? And you can put that in the calculator, but you will. You will. It's 180 degrees. That guarantees that the three angles combined is 180. They are supplementary. That's what we needed. By the way, what we just did pretty much is not going to change, not in any of the problems, because we're just looking at the interior angles of a triangle. That's our objective for the day. So on this example, right, we got three angles. I got 55 degrees, I got 41 degrees, and I got this angle, which is showing as an expression. That's okay. In the end, though, we are solving for x. That's what we want. So we're going to take all three angles again. Right? I got the red angle at 55 degrees. I got the purple angle at 41 degrees. And then I have my green angle at 3x plus 12 degrees. Okay, so I'm just listing the three angles, but now that I have them listed, I know if I add them together, I need to get 180 degrees. If it was not 180 degrees, then it would not be a triangle, or it'd be some funky looking thing. Okay? So, well, hey, look here. I see again, I got three constants that I need to combine. I got positive 55, positive 41, and positive 12. Well, let's go ahead and add those together. And I'll go to my calculator because, I don't know, I feel like I'd make a mistake if I didn't. When I add those together, I get 108. Okay, well, I got my positive 3x there, which I can drop. And yeah, this is just going to equal that 180. All right, so this is our new equation. It's not that we've changed any of the values. We just combined some like terms so that we changed the way that it looked. Okay, but it has exactly the same values as the original, just like we've seen before. But now that I have this, I can, so that's what I'm going to use. Right? So principle of equality, again, which just says whatever you do to one side, you'll have to do to the other side. So my 108, I need to zero that out to make it go away. That will allow me to just drop the 3x. It's called isolating the variable. It's just, yeah, minus 108 on one side, you got to do the other side as well. That's the principle of equality. Zeros that out. 3x then would now equal 180 minus 108, 72. And last up, again, we don't want 3x's. We really just want 1x. And we want to know what that is. How do you make a 3 a 1? Principle of equality with division. Just, yeah, if you do it on one side, just make sure you do it the other side. So I put 72 divided by 3 in my calculator. It says x is 24. Okay, now again, this means that you could solve for this angle if you wanted. You'd have 3 times 24, and then plus 12. And I just put that in my calculator there just to check. That means this angle would have to be 84 degrees. Okay, but what is 84 plus 41 plus 55? It's 180. Boom. That's what we needed, and that's what it is, and we are done. Now this example, it's exactly the same, but now two of the angles are expressions. This one in red, this one in purple as well. But we do have this angle right here, 43 degrees, right? So I guess I'll start with the red one. It doesn't really matter because I'm just listing them, right? I got 3x plus 18, that's one angle. I have the purple angle, 6x minus 16, no problem. And then also the green angle, which we know is 43 degrees. Well, if I were to add those three angles together, you guessed it, it'd have to equal 180 degrees. It has to, okay? Now the equation is bigger, which makes it more work, but if you understand the work, then it's not like it's more hard work, it's just more work, okay? So on this one, I'd say look at any like terms that we can combine. I got some x's that I can combine on this one. 3x's and 6x's. That'd be 9x's. But I also have these constants, right? 18, negative 16, and positive 43. Of course, in the calculator, I just make that 18 minus 16 and plus 43. And yeah, it looks like we get 45 there. Positive 45, so I'll show it as plus 45. And yeah, this is just going to equal 180. Okay, so we just simplified the equation, so now we're just looking at a two-stepper because I can zero out that 45, right, by subtracting 45. But if I do it one side, I've got to do the other side. So that will zero that out. I can then drop my 9x's, which equals 180 minus 45. I better check my calculator, 135. And yeah, we are solving for x, so the last thing I want to do here is just make this, instead of 9x's, I want 1x's. And that's easy enough because I'll show the division differently. I'll just use the fraction line for it. 135 divided by 9. Again, I'm just going to my calculator, it says 15. Now that is as far as we need to go on this, but like I said, if you needed to, you could solve for these other angles that we don't actually know their measurements. So, 6 times 15 minus 16, 74, my purple one, 74 degrees, or 3 times 15 plus 18, 63 for the red one. All right, and then there we can actually see, if you were to add all three of these together, 63 plus 74 plus 43, again, even if you're using the calculator, you should know you're going to get 180, and we do. So it even checks off. I'm doing that really just to make sure that this value of x would make this original equation true. Remember, that's what a solution is. And that if I add these three together as well, once I get these numerical values, if I add them together, I should get 180. So this one is a little different, but the process is the same. So we got the three angles here. We are not solving for x, but we'll have to solve for x in order to find the measure of the largest angle. In the meantime, though, take a minute, try this one out, and then we'll go over it, okay? So we do have the three angles on this one. We got 8x plus 8, and we got 5x plus 11, and also 5x minus 1. So we got the red angle, which I'll start with, 8x plus 8. Then we got the purple one, 5x plus 11. And then we got the green one, 5x minus 1. Well, I know if I were to take these three angles, since they're on the inside of the triangle, if I were to add these together, all three of them, I should get 180. Okay, so again, is there more work? Yes, kind of. Is it more hard work? No, I wouldn't say so. But I can start combining these, right? I got 8x's, 5x's, and another 5x's. Really, it's 8x plus 5x plus 5x. That's 18x's. And then I got my constants, 8 plus 11 minus 1. That should also be plus 18. Well, this will equal still 180. Okay, so to solve, I'll go ahead and subtract 18 from both sides. Now remember, the purpose here is to solve for x. However, x is not going to be the answer in this case because it said to find the measure of the largest angle. So what does this do? It takes the 18x, allows me to drop it so that it's isolated 18x's. And then I can zero out the 18s there. And 180 minus 18 is 162, it looks like. Then finally, to solve for x, which we do need, although it's not our final answer, I need to make 18x is 1x by dividing both sides by 18. And again, I'm showing the division here different. Well, in my calculator, 162 divided by 18, enter 9. Okay, so x is 9, right? So I go to this, I guess I'll start with the red one again. Okay, so again, I'm saying that the x value here is 9. So I got 8 times 9 plus 8. Okay, so in my calculator, 8 times 9 plus 8, 80. So the red angle we know is 80 degrees. Now, is that the biggest one? I don't know. I think it is, but let's find out with these other ones, okay? So I'll go to 5x plus 11 there in purple. See if I can get rid of that garbage. Yeah, there we go. And once again, I'm replacing the x here with 9. So this one is 5 times 9, but plus 11. So on the calculator, 5 times 9 plus 11 tells me that this one in purple is 56 degrees. So as of right now, the biggest angle is 80 degrees. And I think at this point, some students would just take 180 minus 80 minus 56, and that would give us this angle. But I'm still going to solve for it with the expression, okay? So 5x minus 1, right? Right now we're saying the x is 9. So 5 times 9. 5 times 9 minus 1, that would give us 44 degrees. Okay, now again, if I add these together, 80 plus 56 plus 44, enter, I get 180. So that checks off, okay? This is the measurement of all three angles. But again, the last thing we need on this is what's the largest angle? As far as I can tell, it's 80. Bam. Now the last example we got, I can solve equations made from the inside angles of the triangle. That's also known as interior, but I also don't think you care. We know we're just adding the three angles together to get 180. And then we're solving for either x or, I guess, largest angle sometimes.